Nemáš žádný? Tak aspoň tak. Tak, můžeme.
Jednou pro kameru.
Hi everybody. I'm Honza. I'll start talking a little bit about testing Django applications and everything, and because I'm super lazy and I didn't want to prepare a slide, so I'll have actually some live demos. So let's hope that the demo gods are with us and it will actually work. So what I would like to show here is how to create Django application, potentially a reusable one. We are going to use the comments example. So we are going to create an application that does commenting, because we sure don't have enough of those. And without ever opening a browser, without writing a single line of a template, and it will all work just through tests. So what I have here is a basic structure of the project. I didn't start from scratch. Just getting rid of some. So no, it still doesn't fit. So it doesn't matter. This is a project template that's generated from our very own template, which is called it's a very simple repository that basically has only one shell script. So if you go in there, there is a brand sh. You see everything is called like capital app name, test underscore app name, and everything. So when you decide you want to start an application, you just say I want to start an application that's called our comments, and it will magically do everything. So you can see that it actually changed a lot of stuff. And made it into a fully working project. So that's where we are. That's where we are now. It's an empty project. It doesn't have anything. In the test directory, we have some basic tests, and I'm really sorry. My laptop didn't work. So yeah, I really don't like PYC files. In the test directory, we have a magical command run test. We'll dive into that in a second. And this is basically a sample Django project that's configured to work with our application. So we can see that in install apps, we have our application, we have the urls.py, we even have some very simple tests. Now if I run it, just by running the run tests, I see that one of the tests are failing, which is perfectly fine, because 1 times 1 really shouldn't equal 2. Note that I already made some we already made some choices in this app template. We are using nose, and we are using nose not just to run the tests, but also to use the assert statements, assert functions, for one and simple reason. These assert methods or assert functions are actually all just taken from the unit test module, but they're actually made into proper Pythonic underscore notation instead of the camel case that really doesn't fit anywhere into the Python world, and it's just there because all the testing originated from the one proof source, which is JUnit. So these are the very same method. Nose tools actually has some magical piece of code that will import the unit test library, inspect the test case class, and grab all the assert methods. So that's why it looks a little bit different. We can see that we are using here the test functions that run with nose, and if we explore the magic, that's the run test, there's some random code. The important part is Django settings module and a function that will actually run the test. It just calls nose run exit, but by default it adds some parameters that we want there. If it's called without any parameters, which is what happens when we do Python.py test, which you should always do, because that's the standard way how to run tests. So you should always have a shortcut to be able to run this, which is just one entry in the setup.py. So in this case, we are adding a bunch of parameters to include coverage report, to cover only our package, to erase the coverage report before we start, not to capture any standard output or any logging output, and to be verbose and to treat skips as failures. So this is a configuration that you generally want to run in your CI server or somewhere. It's very secure. You generally don't run it. What you generally run is you just run this file, in which case only these options are added with coverage, cover package, and cover erase. So what it will do is it will simply run it. It says that we have 100% coverage of the package itself, but there are 0 statements, so really nothing going on, and we have one failing test. So this is where we start. This is an empty project. If we look into the application, it's perfectly empty. So let's start with defining the models here. I'm sorry, I don't really intend to type anything, so I'll just quickly jump forward. So we have created a models.py file with a bunch of imports that are not important and one model. So there is a model which represents a comment. It's bound to an object using generic foreign keys from Django. It was submitted by a user. It was submitted sometime. It had the text and has a Boolean field whether it's been moderated or not, whether it's public or not. So to make a then there is one method defined, and that's called isPublic, which basically just checks if the comment should be visible on the site. This is typically something that we would be calling from the template when rendering this this method. So how do we test it? We created a test case. Note that we are using simple test case from unit test. No need to use the Django's test case. We don't talk to the database or do anything fancy, even though we are testing models. And that's the first trick that I would like to share with you. You should try and write your methods on your models in such a way that they don't require the ID, that they don't require the foreign keys or anything like that if it's not absolutely necessary. So for example, in this, I just instantiate the model, I don't save it. So I don't talk to the database. This will be super fast, doesn't require any setup or teardown, and it will just work, and I can do the assert false, that it really isn't public if it was created in 10 days from now, and it really also shouldn't be public if it was moderated. So two very simple test cases, and what happens if I actually try to run it now? I get 5 tests. Some of the tests were there for the tools that we'll be using later. So if I actually want to see the tests, we see the 2 tests that are relevant to us. They both went okay, and we have 100% test coverage. 100% test coverage is good. It doesn't guarantee that the code is bug free, but it's some indication that at least all the branches were executed at some point. That was the first step, defining the model. So the model alone isn't really that interesting. So let's move on. in this we just added a method to actually change the data. And this is a place for tip number 2. It's perfectly okay to cheat sometimes in the code and add in some hook that will be mostly useful in tests. So, for example, in this we added a method to moderate the comment, to actually mark it as moderated, and we added an optional argument called commit, and which, if it is false, it will actually not commit it to the database. It will actually not save it. This also enables us to keep the advantage of just saying assert true, basically run the test without ever talking to the database. No need to create the overhead. You also see that we are creating an incomplete model that we would not be able to save. But we don't care. We only care about the moderate flag. So it's perfectly fine to just say false, commit equals false, don't save it to the database, just create it in memory, run some asserts against it, and it's done. So, very interesting thing, only 0.1 second. Like, if we actually were to talk to the database, it would take a significantly longer time. Even if we use like an in-memory SQLite instance or something like that, it would still be more than that. I'm still amazed that it's that high, but this is on my computer, so I'm not going to comment on that. So that was the first important part. Always try to make it a unit test. It will be faster. It will be more specialized. For example, if this test actually fails, we know specifically which line failed, which method failed. If it was an integration test, if it talked to the database, we don't know if it was exactly there or some other parts of the entire stack. So that's the important part about unit testing. They are very localized. They only touch one unit of code. Typically, one class, one method, one function, one blah blah blah. And so that's one part. The second part is it runs in complete isolation. It doesn't talk to anything else. It just creates an instance in memory and runs some assertion. Very fast. And because it's fast like that, there is absolutely no cost in running this every time you hit save in your editor. You can always wait 0.1 seconds. Like, even if you type way faster than me, you're not going to lose any coding time when you actually wait for these tests. So that makes the transition from something that I wrote in the past 2 hours has failed to something I wrote in the past 20 seconds have failed. And I sometimes don't remember what I wrote 2 hours ago. I almost always remember what I worked on for the past 20 seconds. There's been examples where it wasn't true, but generally it's the case. So, easiest way how to test models: treat them as regular classes, don't save them to the database, and just have this work. Know that you can even simulate foreign keys like that. For example, if there is a foreign key to user, I can just create another in-memory instance of user and just assign it to the foreign key. So anything that uses .user will still work, and I still haven't touched the database, and everything still holds together and is super fast. So, moving on. Notice that in the previous test we still had one line of code that wasn't covered, and that's bad. We probably want to cover anything more. So let's add our first integration test, a test that will actually talk to the database, and that's this one. So now I'm extending the Django test case, which was actually imported from Django test case. It's a subclass of the basic test case that provides some useful functionality. For example, it creates the database for you and flushes it after you're done. In our setup, we will just retrieve the proper content type. We'll create a user, and here we'll just create a comment, we'll moderate it, not passing the comment false as we do here, and then verify that when we retrieve it from the database again, it's still moderated. So note that we are not testing whether it is public. We are just testing whether the flag has been set. We are not testing the higher level functionality, which means that it should be hidden. No, we are just testing the smallest piece of code possible, that the attribute has been set, that the method has done what it was supposed to do. So very simple test that should bring our test coverage to 100%. Yeah, this number now makes me a liar because now the tests are faster. I have no idea why, so I will not even comment. But this is generally what I do is I would write unit tests for all the possible cases, and then write one possibly expensive integration test to basically just verify that it all fits together, that there are no typos, and that's generally enough. Because I did all the corner cases in the unit test where it's super fast, it's super easy to write, it's super convenient to run, and it's very helpful for debugging. And then I just ran the one big integration test that makes sure that everything integrates well, that everything fits together. Generally, if I have the one happy path of the integration test, happy path means that I assume everything is going right. So if I have one test like that, it's generally okay, because the unit test will pick up all the corner cases, all the weird shit, and the integration test is there just to make sure that we haven't missed anything obvious, like not calling save somewhere or having a typo there, or whatever. So let's move on to something even more challenging. Sometimes we will have methods on the managers, where with Django, the model basically relates to one row in a database. The manager would basically relate to one table. So here we have created a manager for the comments with one method. The method works that it retrieves the list of comments for one object. So we just assign it to a model, we designate its manager, and we write a very simple test. So let's see the test, and notice there's also one additional thing. Before we only had one test, so we were actually creating the comment inside of it. Now we have multiple tests where we want to create an object, so we perform the miracle of code editing, and we actually factored it out into its own method. And this is additional nice pattern that I would like to show you. And it's basically a method that will create an object for us, and by default it will create a reasonable object, and it allows us to actually redefine any and all attributes of that model. So if I just call create comment like this, it will create a comment for the user. So it will be the user commenting on himself, on themselves, and with the text first. Not very imaginative, but it works. If I want some other things, for example, I want to comment on some other object, I'll just supply it as a keyword argument, and it will get passed to the objects.create on this line. So on line 39, that's where this will happen. So very simple. Technically, this would be a factory in Java terms. In normal terms, it's just a utility method that will create the models for you. So that was the first change that we made. This is the test that was here before, just with some of the code factored out, and here are the new tests for the manager. So we create 2 comments, and then we verify that if we ask for the comments on the content type itself, we only get 1 comment and we don't get the other one. So the list is the query set return has a length of 1 and contains only the 1 object that we expect. Also, we verify that when we create a comment that is moderated, it will not appear there. Also, a comment that should be published in the future will not appear there. So we have all the different cases covered, and super simple. Let's make sure that it still runs. So we are now up to 10 tests. We still have 100% code coverage, and we are free to move on. So very simple steps, very iterative, and I never had to open Python shell to try something. I never had to open a browser or create the working application. Notice that I still don't have any views, any URL patterns. I don't even have the definition for the admin. So if I wanted to test this, I would actually need to open up a Python shell and try it out. And that would be the exact same amount of effort as it is to write the test. But the reward is significantly different. If I run it in the Python shell, I only get the one run out of it. If I create a test, it will run whenever I hit up and enter. And otherwise, I would always have to retype it to the Python shell or just copy paste it and something, and that's really boring and repetitive task. And boring repetitive tasks is something why we actually invented computers for. So why not use the computers for and actually delegate this to a program? So, everyone with me so far? So, let's moving on. We're here now, so 6. Sure.
And I totally forgot, what is content?
Content type is basically a meta model. It's one model for each models that you have. So if you want to, this is. Thank you for pointing that out. For those of you not really familiar with Django, so we have basically a pointer to. Thank you. Pointer to a table, pretty much, and then the ID in the table as 2 fields in the database. And then we have like a wrapper around it that will allow us to treat it as a regular foreign key. So this basically allows us to create a foreign key to any object that we have, to any model that we have. Yeah.
Okay.
So it's just a Django thing. So content type is part of Django. We can see that it's in contrib, Django contrib content types, and
These are those like when you need to actually relate to different tables due to inheritance, for example. Yeah. For example.
You don't need to do inheritance with this. You can refer to any table. For example, in the tests, we can see that I've been commenting on a user model. I've also been commenting on the content type model on its own. With this, I'll be able to even comment on a comment.
Comment on a comment. Yeah, that's okay.
Yeah.
Usually the use cases for are actually different tables.
Either that or generic applications like this, where you really don't. When I'm writing this application, I want everybody to be able to use it. So I cannot hardwire some foreign key to some like commentable object. I want people to be able to comment on anything. So that's why I use the generic foreign key.
How does it get saved in the database?
As these 2 fields. A foreign key to a model that's content type and a text field that contains the ID.
And it's in the table of the model, or?
Yes, it's in the table of our comment model.
Yeah,
yes.
So one row can have one association with whatever?
Yes.
Or multiple?
One.
Just one.
Just one. It's one field. Obviously, we could have an intermediary model and turn it into many to many, but that really makes no sense for comments.
Can I have another little question?
Sure.
The moderate method, you are using there the comment attribute?
Yes.
And do you actually use it somewhere else in the code, or this is just for the testing?
So I might use it, for example, if I wanted to do some batch processing. So I wanted to change a bunch of models and then save them all at once at a later point. So for example, I would be editing a form or a form set, and I would be editing 10 comments on one. So I'll call moderate on each and not save it in the database. And if everything goes well, I'll then save them all manually. Or if I'm doing more stuff to the model, I'm not just calling the moderate, but I'm also changing the submit date. So I don't want to first change the submit date and then call moderate and have it magically save the model. I want to change the submit date. I want to call moderate with comment false, and then I want to save it myself to be explicit. So everybody who sees that will know that the change to submit date will actually get saved. Make sense?
This will still save them sequentially, right?
Sure. Yes.
So no, it's like the same. You just have the method moderate that sets the status and then separate method for saving.
Which you yes.
Yeah. Okay. I was just wondering if
It's just a shorthand.
Django does sessions based on request. If you're talking about database sessions,
It's configurable and
Yeah,
stuff, but
sure.
typically it does transactions per request. But
yeah.
this is not just for transactions. This is literally if I do 5 different operations on the one model, and I don't want every single operation to call save. I want to call all these 5 operations. Imagine if I have also.
Can't you just wrap it with one transaction, like a database transaction?
Yeah.
Yes, but sure, one database transaction with 5 updates.
Matter, but the SQL server will optimize it.
No, because it will still get sent sequentially, even as part of one transaction. It will get sequential. It will get sent sequentially as 5 individual commands to the database, and then a commit will be issued. But all the operations will run sequentially in the database and will run on its own. Sure, in a transaction, but still, you will have 5 operations in the database. Okay. 5 round trips to the database. Generally something that you absolutely must not do if you have any amount of traffic on your database.
Well, I thought like it's perfectly fine to use transaction, and after that, like the modern database engines, like they will just optimize it. So if you have a lot of commands,
no, that's not true. So for example, if you have set to now self. Not my notebook, not my notebook. So, and if I now have a comment and I want to say set to now and moderate. Even if I do this inside of transaction, it will be 2 round trips to the database, 2 separate network trips, and it will be twice as expensive.
Yeah, but you don't need to call the save every time. Like
Yeah, you are
No, exactly. That's why I use this, and I do save. And this way, I have only 1 round trip.
Yeah, but I mean, you don't need. Yeah, but
he
he will explain it.
He knows what I mean. But my first concern was that if you don't actually need the thing here, like you can always call save. If you just use it for tests, you should rather mock the object and like mock the whole save methods or all methods that are working in the database.
Sure, that's at least 10 lines. This is 1 line, and I don't care.
Well, yeah.
Sure, it's from a purist point of view, it's fugly, but it works and it's practical and it makes sense.
Yeah, but now we are mixing the logic for testing with the code.
No, but there is no. But here is a legitimate use case how to use it in code. Like it's not just there for testing. Sure, it's mostly there for testing, but there is a legitimate use case. And even if it were just for testing, so what?
Well,
like
yeah,
I don't care.
You are mixing 2 layers together, you know. And
Yes.
Yes,
and I'm already using Django, which mixes all the different layers of MVC together. I don't care. I leave that in a textbook. Like,
I have an idea, everyone, but you will, so like decorate your methods with like commit decorator that will do same on the object if like.
Or you can decorate the class that
Will
change the meta class of the
Can
class.
we
and
continue?
sure. If you have a free week to implement that decorator, I just put in one line.
You know,
This is getting a bit out of hand.
Yes.
We can discuss it after all the other talks.
Yes. Yeah. I agree that it's not pure.
Yeah, that was just a quick question.
Yes. Well, the question was quick, but the fallout.
Yeah.
Okay.
Let's continue.
Let's continue. So now we want to actually start to have some. Wait. I skipped something. You made me skip something. So now let's start doing something interesting, something that actually that should actually work. So let's create a view. This is a perfectly normal view. What it does, it basically gets the content type for the ID. It's using this convoluted method because this will always be cached in memory, not even in cache. It will be on the object. And then let's retrieve the object itself. Verify if the object doesn't exist, raise 404, and then retrieve the query set of the comments and render a template. Very straightforward view, nothing surprising. So let's write some tests. So what we will do is we'll use the Django's request factory, and we import the comment test case, which we import primarily because it has the create comment method. And in the setup, we just create some comments, and then we test all the different cases. So if the content tag doesn't exist, it should throw 404. If the object doesn't exist, again throw 404. And then if the object exists, it should return, it should render the comment list. Notice that this is the end of the comment. I haven't created a single template. I haven't configured any template loader or anything like that. And that's because I am using actually a template response, which is a lazy object that will just take the template and only render itself when asked to. So when the data should be sent over the network. Until then, it's just a placeholder, so I can verify that on the placeholder there is a comment list in the context, and it actually contains the list of comments that we created up there. So super simple test. No, even though we are testing a view, we still haven't even define the URL mappings. We didn't have to create a template. We are just testing that the view does what it's supposed to do. That it retrieves something from the database safely with raising 404s when required, and that it tries to render the correct data. So a unit test for the view. Technically, it's an integration test because it talks to the database, but from the point of view of the view, to be a little more convoluted, it's a unit test. So very simple thing. Again, let's. No. That's why I said previously that Django just doesn't do MVC. That's just. Technically, the MVC would be the URL dispatching more than the view. So still everything works. So let's move on to the actual URLs. So the order that I'm actually showing you this is not random. That's how you typically work. You create a view, then you create a URL mapping for it, and Before that, you've created the model and the methods on it. So this is how you work. This is basically just replay of a TDD approach to writing Django applications. Sure, I maybe should not have everything in one commit always, but again, I'm not one for purity. I'm one for getting shit done. So basically, the only thing that this one tests, it doesn't need to test the view. It just needs to test that the proper view is called. So it will basically just get the URL. Basically, now we are actually registering a template. Another one of the features of the app template that we started with. There is a template loader that's purely in memory that we can use from the test. So we imported here somewhere, here, line 10, and then we just register a template under the name comment list.html with the content of hello world, and then we assume that this template actually got rendered. So we just verify that the response content is like this, and we again verify that the context actually contain the proper data. So super simple. Most of this was copied from actually the tests above, the two main asserts. We just had to register the template, but again only just in memory. No need to create a file. No need to keep track of what each test needs for templates. It will just create a template on its own. The template loader will actually make sure that when it was registered only casually, it will only be there for one use. So I don't need to clean the template loader. It will just, after this test runs, it will be clean again. So that was one more step in our TDD approach towards a working application. So testing views. Again, I tested a view. I tested. Sure.
The template loader, you set this like in Django, you have to globally set it in some settings option, right? So
Yes. So this
you
is.
do it in setup.
So now here is a settings file where the where I have the testing template loader set up, and then basically it has just an in-memory dictionary of all the templates that I just once register something to, and once it's used, it will get removed. So that's why I have a separate settings file just for the tests, so I can do shit like this.
What do you use for mocking in views?
Mock, but generally I don't. I try to avoid mocking because it's brittle.
Yeah, so that means when you render the page, it always calls for the APIs or the base calls, or you are mocking that?
No, I'm not mocking that. It calls everything.
So, yeah, okay.
How about external services?
Yeah, but if you're like, we have like queues and celery, you know.
Yeah,
so just not that.
With celery, you use always eager, and with other external, that's not a topic of this talk. We could talk here till 4 in the morning, and that's really not what we are here
Let's
to
make
do.
it quick.
Yes, too late for that.
Just a minute.
So there's no quick response for my question, right?
We just go down to
No, well, I do use mocks for external services. Yeah,
Yeah.
that's the quick.
Yeah. It's maybe better, again, when you are testing views, you should test like views, not the database and things like that. It's the integration tests are for. So,
Why? I know it's better from the purist point of view, and I know all the arguments. But have you ever in real life wished that, oh, I wish this view wouldn't talk to the database, when you already have the code? Know that I didn't write any new code for that test, because I've already had that code from before. I've had all the factory methods. I've had everything that needed to be there, because I had to test those methods, that they talk to the database and that it makes sense. I haven't written a single line of helper code to implement that test. Whereas in your case, if I had to mock it, that would be a lot of code. And for what benefit?
Yeah.
Sure, somebody masturbating over a textbook will be happier, but
Let's take you are making integration tests and you are
Yes.
making view tests, and both are accessing the same database, which is again duplicating. And when you have, I don't know, thousands and hundreds of thousands of queries to the same database, it will be just, I don't know, 1 hour instead of half of an hour testing.
no, and generally you don't have that scope with Django applications. If you do, you want to do something differently, and like those are all theoretical academic questions that are valid in academia, not in real life.
Well, yeah. You know,
Okay, can we
I-
discuss this after the talk?
I'm doing this in large projects that have tens of thousands of lines of code, and I can get about 500 tests to run under 2 seconds.
But you are not
Using
running
this approach.
the whole tens of thousands of lines of code, but you are
No, I
running
am.
small applications. Well, that's kind of big.
Okay.
It's not the like engines from Ruby.
So.
Oh.
Tree falls with the woods.
Now, let's move on. So we are now in the process of creating a view to actually create the comments. So first we need to create the form. So we create a form that does all the work, and we test it separately. Note that again we use the commit false trick. This one is actually not written by me. This is part of Django, which actually the model form save method actually has this that allows you to basically just create the object in memory, have you play with it some more, and then relies on you to call the save yourself. So again, just instantiating something in memory. Technically, this is still an integration test because we needed some IDs of the user and of the content type. So here we are actually no, actually not. I'm sorry, I misled you. This is a unit test. It doesn't talk to the database. I'm using the trick that I'm actually I'm creating the object in memory and just assigning it and not actually retrieving it from the database. So that's one more thing, that here I am passing on the user instance, not the user ID, not the object ID, the object itself, which enables me to actually just run the entire test in memory. And it's very fast. So the whole thing I do is I instantiate the form with some data. I verify that it's valid. I create the comment from it and verify that the comment looks as it's supposed to be. Again, some purists might say that this is a wrong test because it has 4 asserts. Instead, I should have 4 different tests, each with one assert, and
That's
sure.
perfectly fine.
So that's where you draw the line. No,
Yeah.
I'm sorry.
Oh, like it's
I actually had a
the
guy
big test.
complain about this today.
Yeah?
So, moving on. So now all we have to do, and again you can see that we are always moving in very small steps. We've just created the form, it's not connected to anything, and now we'll actually create the view. And what it basically does, it pretty much only wraps the form. So I could have used just a generic view from Django, but I wanted to actually have the code. So it just basically retrieves the object using the factored out logic that it shares with the comment list view. It will verify that if it's a post request, it will actually use the data. Otherwise, it will just instantiate an empty form to be rendered and shown to the user. If the form is valid, just save it and redirect. And the test is super simple. It basically just says that if we are just doing get, we will get the render back. So again, since we are using the template response, no need to create the template, no need to actually do anything. We just verify that there is the form, and the form that's in the context is actually the form that we want. And then just posting the data that it again actually creates the comment. We really don't need to verify that the comment looks like we want it to, because we know it's just using the form and the form has already been tested. So we just verify that there is a comment, that the form safe actually has been called, and that the redirect has been returned, and that the comment is there. So again, just one tiny step, one tiny step towards a complete application, and the next and last step finally is just again an integration test for the view, which just defines the URL and runs the test using the Django's built-in client. So that's it. These have been very simple steps how to create a simple application in Django using test-driven development, not talking to the browser at all, not doing anything except writing tests. We can verify that the tests still work. They're still super fast. We have still 100% code coverage, and we are very, very happy. Some of us are. So these have been just basically a collection of tips how I do things. Some of them are generally useful. Some of them are apparently questionable. Controversial. But it's very useful. I've been doing this for 4 or 5 years this way now, and it still works even for larger projects that have been in production for 4 or 5 years, handling a huge amount of traffic. And tests like this that I can rerun very fast, very quickly, that I can run it per application, so I don't have to run it from my project. I always go to the application and just test the application separately. And it has worked very well for me, and it makes me proud that I was technically a web developer for 3 or 4 years, and I have never actually opened a browser to write any code. So that's it. Any questions that will not cause us to spiral out of control?
Has anyone ever noticed that the curly braces kind of look like sideways mustaches?
Next question.
That's why there's a JavaScript rendering library that uses that, and that's called mustache.js.
Get it out of my head.
Yeah, there's also Ruby thing called mustache.
Okay, some relevant questions. I'm sorry that was my fault. I didn't specify. Some relevant questions. Okay, thank you. This code is publicly available at my GitHub account. So at github.com/honza/rcomments, and it's all there. It's all runnable, and it actually. Let me. What?
Minus V.
There. Thank you.